I think this is where most AI tutorials fail. Not because the code is wrong, not because the concepts are wrong, not because they built something wrong, because they stop early. They saw how to build something, how to make it work, and then they stop. But real engineering start after the demo works, because the moment your MCP touches the internet, everything changes. Now stranger can talk to it. Now bots can call it. Now bad input can break the system. And now security matters. Today we are crossing that line. We are taking our MCP server from our cool demo to something that we can deploy in the production. And let's do it. Hey everyone, welcome back to this series. I'm Nitin Kumar. In this series, we are building modern AI agent from scratch, first learning the concept, and then we are working on the code side. In the last couple of episodes, we built MCP server. We built how to we built the system that work actually how to connect MCP to our OpenAI, and then everything was working. But there was one problem. The server lived into our system, into our local computer. Today we are solving that problem. By end of this episode, you will understand streamable HTTP, authentication, MCP security, production deployment pattern, and most importantly, you will understand what separates a demo from a real system. So let's start. So last episode we said, uh, like server server is ready, that we built the server using fast MC, and so agent is connected. But one final step remains is- that we left. That is the production. And production changes everything, because production means real user, real traffic, real security, real consequences. And today we are making our MCP server production ready. So everything we have built so far used STDIO, and STDIO is amazing for development. But STDIO only talk to local processes, can't reach internet, no authentication, no encryption, very fine for development, because there is no internet, there's no browser, no remote agent, no external users. And that's why modern MCP servers increasingly use streamable HTTP. And here is the beautiful part: the protocol doesn't change, only the transport change. So let's just see a very simple line. So in our previous codes, in our last episode, we are just starting our MCP server by mcp.run. This is standard using stdio. But if we just change one line by using this transport equal to streamable HTTP, and that port that we are using in the last episode also. So now by this line, we are using the same tools, same decorator, same protocol. But now is this my MCP server is reachable from internet, anywhere from internet. Let's see how we can make it the real code. So if you see this part, that's how we started our MCP server. That are the tools that we define. And this is the simple way that we are using to run our tool, like using MCP, this mcp.run. But now if we change this line equal to MCP run transport streamable HTTP, and we have defined the host equal to 000.0. Now let's check it. How is it working? So we will run this code 01. The server is starting. Okay, my server is starting. It's listening at 8,000 port. Can I test it? So I have this testing script that I have written. So it will check is my server is connected. Okay. So now my server is connected, and it got okay. What are the tools list? This one with some example. And this is the result of the capital of France, Paris, capital of the temperature of Paris, and calculate this experience. So now all tools are working that we have seen in episode 8. Everything is now reachable. So at that time call from the different setup. Now let's go back to the our some next important part. If you have observed, our MCP is now connected. So most people think MCP now competes with HTTP. It doesn't. MCP rides on top of HTTP. Exactly the way websites do. Same as API. And that's why MCP adoption is happening so quickly. It fits into the existing infrastructures. So now we have a new problem, and that's the scary one. Imagine I post this URL online. What stops somebody from calling my tools? What stops a bot? What stops an attacker? Right now, nothing. And that's why authentication becomes mandatory. So let's see how we can do something around it. So my server, as I mentioned, my server is public now, and I need to build something. Let's say we have different techniques like BLA token, JWT, OAuth. We have different patterns to make it sort of a lock, and with some key that can only give the access to this system. How we do it? So we have this middleware system. So middleware think is like as a security guard. So every request arrive here first before any tool calls, before any logic execute, before any data is returned. The middleware asks, who are you? Do you have a valid token? If yes, continue. If not, access denied. Simple, powerful protection. Now let's see how does it work. And if something is a bad, then it will break. And this give me the very good security, and that is needed for the production system. So this is the app. We will add this layer, middleware layer, mcp.middleware with bearer authentication, middleware authentication, and I'm passing some API key. Just for demo, I have created my this key is simple as anything MCP server, but that is not uh, sort of a suggested to go in the production. You need to create more complicated is the key, and not hard coded in the code. Definitely, just I am showing this line just for the demo purpose. Okay, this is the sort of a warning in the code. Now I have this function that will authenticate this middleware authentication key. If it's correctly working, it will say access approve, and then if something is say token is missing or maybe invalid key, it will just check token with self.api key. Simple, very simple logic, no complexity. Now let's see if I have this, if I'm trying to access this server with my token, how will that work? So let's see. I will start the server that is and now my server is running properly. Now I will test by my other script that I have to test authentication. So now I will pass three settings. So in my first, I gave my right sort of a key. If you can see this code, I have this code that first check with a good token, check with the bad token, and check with the no token. So there are three type of things I'm going to do in the demo that I am running in the live demo, and I will run all three settings and see how this thing is working. And when I run this script, so first it is use the right token and say, okay, I have the tools available, all this thing is working, access granted, tool work. Then I said, okay, I have the wrong key. It said access denied, bad tokens are blocked. And third one is without any token, it said no access, no token, no access. That's it. And that's how I'm seeing why even to access this my MCP server now needs a valid authentication token. It saves my life from unwanted traffic to my MCP server. Now, this is very powerful. If you can see, sort of a how I am saving or more like guarding my MCP server. So this is exactly the same pattern used by most popular infras or services on the internet, like maybe GitHub, Slack, Notion, and many more production MCP servers. The implementation changes definitely, but the pattern stays the same. And now, okay, let's come to the different story. Imagine your MCP server controls GitHub repositories, Slack channel, production databases, customer records. And would you expect that without any authentication? Of course not. And that's why authentication is not optional, it's required. So, who owns the user consent? So, most people think it's the protocol. No. Maybe the server. No. The host application owns the consent, like the GPT, ChatGPT, Claude, Cursor, your application. So the host decide what tools users see, when users are prompted, when what servers are allowed, and the protocol simply transports information that intentional, and it's one of the smartest decision design in MCP. So very simple. Now let's say okay, our sort of a thing. Okay, authentication is perfectly fine. Now I have the authentication layer, middleware layer in my MCP server. Now, if you see on the internet, most of the tutorials stop. That's it here. Most very rarely you come to the authentication. That you will not find any sort of a very rarest video you will find on that after they are going next ahead after this authentication. So are we done? Definitely no. Why? Real systems needs more than this authentication and MCP server and all these things. Real production system needs logging, validation, monitoring, health check, configuration, error handling, and that's sort of a things we needed into our system. So let's look at what production actually requires. So we will not build the more sophisticated system, but just to show the demo, I will go into very basic things what are needed in the production system and how we can build it. So uh, this is sort of okay. Now let's go back to the system. We have this production checking. So what we will do, this is sort of a logging that we do. We will show in the even the tool. And this is the middleware authentication that is required for the connection. And what are the things? We need the validation. If someone pass a wrong input, will my system will crash. I don't want to be get crash. So that's why I need more validations. Like if someone is asking just the answer from these cities, because in a real production system you expect a certain inputs that you can make your tool to handle the expected inputs. So that's how I added one more layer to get the inputs validated. Okay. Now let's see. This is very important. Let's say you are just checking. Someone is asking some query from your databases. So you can just check is this customer ID is valid or not. That is the one of the thing is validation you can use. Just think about it. Okay. Now second part is health check. This is very important. Your tool is running now. Now when you are requesting something, is the tool are running properly? That's a health check. It's sort of work as a heartbeat. It's keep checking, okay, my health, my tool is working fine, they are responding, so health is perfectly fine. So it's very important to check the status, live status of is this everything is working fine. That is the one of the health check that we are going to add. So and now let's see, we add the logging and we see the monitoring how the things if we are sending some request or not. This is very simple. The script we are going to do. We are going to do all the calls. First, we will check the health status. Is my this tool called health check that I wrote here in my code. This is the health tool. I will check this. I will first call the check my health. If server is healthy, then I will check the valid request with passing some random cities and is the cities available or not. Then I will pass some bad cities that I'm mentioned, bad city or maybe some valid I mean, more invalid request, bad country name or something. So maybe it's more around invalid inputs. So how my server handle these things? So I don't want to my server get crashed when someone enters some some very basic valid invalid input. So let's see how does it work. So let me start again. So I will start my the production checklist dot py. That's the code I was showing, and my server is running. So how I'm going to see the logs or something, how the logs are flowing and how can debugging work. So if you see when I run this thing, so it's called the tools and it says server is healthy. And if there is a valid request, it say okay, request is valid. And if I say bad input, it say okay, return error plus valid input cities because I error is unknown city, Atlantis. I don't have. I have supported input this and get capital. I am just debugging. That's why I'm showing what I have. I don't want to be so in the actual user. If they are entering some bad input, I will say, oh no, don't enter the bad input. Use enter these sort of input. I don't want to show the actual input because they can bypass this. So I'm just for debugging purpose in internal how we deploy it. We just see and more like the valid invalid country. What are the countries? Wakanda. I don't support the Wakanda. I support these countries same as the previous input, and that's how I see all these things is printing everything is responding correctly. Can I check my logs here? This is the logging. If you see this log that with the timestamp, and this is the information info tab. So my processing request type is this tool called health check and tool completed health check. Next is processing request for type list tool request and tool request, get weather, get task tool completed, again, tool called, tool completed, get capital, tool completed, all these things. So now, very interestingly, very beautifully, I am able to see all the logs. So bad input, if you have seen, bad input have not crashed my system. It's working properly fine. It's just throw me some error and said, okay, you need to enter a valid input. But my production is working, my system is working properly, perfectly fine. And that is the production thinking. This is where tutorials ends. I'm not saying any. Tutorials mostly end here. But this is where engineering begins. Anyone can work on the demo, and demo works, cool things work on the local system. Production system require trust. Trust comes from the security, observability, validation, reliability, and discipline. So what are things we have completed? We have seen the HTTP, authentication, validation, logging. And you don't need anything in one day, everything at one day. But you start with authentication, HTTP, validation, logging, and those four things alone will put you ahead most of your hobby projects to make into more production side. Okay, so we are done. We have explored a lot of things. Now what we know from our this couple of episodes, we know why MCP exists. We built the server, real server. We connected to the OpenAI. In this episode, we secured it, we deployed it, and operate it. Now you understand the complete MCP life cycle. And now we have reached into an interesting point. We have tools, we have agents, we have MCP, we have security, we have production infrastructure. The next logical question is, what can we actually build with all of this? And that's where this series is going to be next. In the next episode, we will build something more interesting by combining all these things. So we will stop building individual parts. We will collectively build everything into a complete AI application, a real application, using everything we have learned so far. So I will see you in the next episode. And till then, keep learning.